Hello. I want to talk about the second thing about classes, basically the idea of overloading. This is one of the exciting parts of classes to my mind. We wrote a program the last time I had a video here, and it's down at the bottom of this, which is the notes I'll give you. And in the main line of the program, when I wanted to add two fractions, this was the fraction class, I couldn't use the plus sign. When I wanted to output two fractions, the sums, I had to do it with couts and lots of complicated items, and I had to use an output function. I don't want to do that. I want to use the same kinds of things I would use for real numbers, doubles, ints, whatever. So, as I think I said near the end of the last video, the symbol plus and the symbol times and the symbol divide, they've already been overloaded. Depending on what kinds of variables they're used with, they have different definitions. If the two sides are both integer, then we do integer arithmetic. If the two sides are both double, then we do double arithmetic. If one's integer and one's double, we do double arithmetic after changing the integer. And if one is a string and the other is a string, we do append. All of those are separate functions, and they're separate definitions of addition. Well, we're going to do the same thing. I'm going to do the plus sign and the multiplication sign and the input and output to fractions. Now, it's a little complicated. There are three different ways to do it. In most cases, you can choose any one of the three. But in the last case, you only have one choice. So, as I said, at the bottom of this program, you will find the original fractions. I'm also going to load it up as a text file. Now, I want to get rid of this. I'm going to keep most of this, but I want to do it better. So my first method is to define a new method. The new actually, it's a function outside of the class. It's not a method in the class, it's a function. We put the const in front of it to protect it. And then we have what we want from it. We want a fraction. And instead of the name of the function, the name is plus. That's what the function is. It's the addition function, the plus. But it's an operator, so we have to put that word in too. And now we have to give it two fractions. And all I'm doing is all that arithmetic I did up above, only now I'm using x and y as the two inputs. And you'll notice I have to return a fraction, and I use the non-generic generator to create the fraction and send it back. It was easier to do it that way than create one in here. But I have to return a fraction. And whenever I wanted to use the numerator or denominator of either x or y, I had to use x dot or y dot because I'm not in the class. I don't have privileges. I didn't define this in the public area of the class. So I can't just use the names that are private. I have to use the full strength of them. So that's the first method, And I have here example I did. We'll look at that in a while. For method 2, I'm going to overload the multiplication sign. Method 2 says, let's define it within the class. So we got basically the same item, but there's a little bit of a quirk here. There aren't 2 elements in the argument list. There's only 1. Where's the other one? Well, remember, this is a method. So where we use it, we'd say something like a dot, if we were using the method. But when we use this, the first argument that the function uses is whatever comes before the multiplication sign. In some sense, the multiplication sign is acting as a dot that says, there's your first argument before me, and here's the second argument after me. But the first argument is, I don't have to put it in here because it's part of the class. That sounds a little strange, but it works. And it's basically the same setup. I just defined it. You can see it's up here in the public section, and I have to define it as usual. And notice I do have the fraction colon. That gives me the right to use num and den of one of the 2. When I say num here, that's a dot num when I'm doing a plus b. And when I say den here, that's a dot den if I'm doing a plus b. So it's I have to use the dot notation for the second argument. The first argument, I just use the names that are public up here. And they don't even have to be public. They could be private. I did an example of that we'll look at in a minute. But those are the easy ones. Now comes the hard one. You may have thought those were hard, but this one is, I don't know who thought it up, but they aren't exactly on my Christmas card mailing list. It's called a friend. What it says is, within the class definition in the public area, we will define essentially a new operator, whatever. Pardon me. Yes. Oh, I have the wrong thing up here. Pardon me. I've been going back and forth between the complex number 1 and this one, and I slipped and left this one in there. Okay, here we are. Now this is fraction. So if you look here, I want to do, we had the output there, and we had the input there. I don't want them that way. So instead, I'm writing this unusual item. Friend iStream ampersand operator, the 2 chevrons, iStream ampersand CN, fraction ampersand A. Well, if you think of it, we use ampersands to pass in the reference to the variables. So this means they're not being passed by value, they're being passed by reference. iStream is an input stream. If you remember, when we have F-stream, you have IF stream and OF stream. Well, iStream is the standard input, is the name for all of them, the file ones and the standard ones out on the screen. So we have to tell it where we're reading it from or writing it to. And there's a worse problem. The function must return the stream it's reading from or writing to. The reason for that is that allows it to go and do the next item that it's reading. If we don't do that, it doesn't work. So we are not actually returning. Oh, dang it, it's still the wrong one. Pardon me. We're not actually returning what we read. That's coming back in the argument. We're returning the I stream or the O stream. Now, these are examples of how I did it. And the friend is inside the class, but when you're outside of the class, you don't call them friends. You just put them without the word friend. Now, I have the complete program here. And what I've done is I have highlighted in bold and in italic the changes I've made. If you look here, I have the definition of input, of output, and of multiplication. And if you remember, we defined addition outside of it as a separate function. So it's further down here, right there. So all those things are new. The best part of it is in the main line. I had a lot of other lines in the main line I did before. Now, it looks just as if I'm working with integers. I see in A, I see in B, I sum them with the plus sign, I print them out, just nothing special, produce the product, do the same kind of output. That's what I wanted. It worked. I wasn't entirely sure that the strings would work, but I will tell you there's a restriction. No spaces in the input for a fraction. I didn't want to spend my time trying to hassle with getLine. Because if I use getLine, then the more cannot be a character. I didn't want that. So I just went and took the easy way out. Now here's the program. If you look at my input, which is the chevrons, this is the wrong program. That's the old one. Now I got to bring up the new one. So that's this one. So here is the way I inputted them. I said, read in a.num. Oh, wait a minute, that's output. Output the numerator, put a slash, and output the denominator. The input was more complicated. For the input, I said, read in a string. Now, since it's not a get line, you better not have any spaces in there. A.num is convert a string to an integer with everything that's in front of the slash. And I had to use the double slash because the slash has a special meaning. And if I want a slash, I have to double it that way. We've had that before when we passed names in of files. Then I said, erase everything up to and including the slash. That's why the +1 is there. And then convert the rest of it to the denominator. So that way I could read it in as I would normally. So let me run the program and see what happens. Let's see. Oh, I didn't ask for, I'm sorry, I didn't give any prompt. I should have, but I didn't. 3/5 and 17/21. It produced the product and the sum by doing the arithmetic there. I'm presuming it's correct. I'm not going to even bother trying to figure out. I'm presuming it's right. And I could keep going. If you want, I could do 1/2 and 1/3. And that's 5/6. And the other side is 1/6. So that's the program. This is one of the more interesting parts of the classes, that you can do all this kind of redefinition, overloading. There's a major problem, though, when we try to overload the equal sign. In this case, it would work. If we said A equals B, we'd get a separate copy, a new fraction, a different fraction. However, when we learn about pointers next week, we're going to find out that the equal sign doesn't work for it. And it's kind of a very frustrating thing that they didn't give us a real equal for classes. But that's coming. You don't have to worry about that now. Right now, take a look at this. I'm putting it out on the web, and be prepared. Your next homework is going to be to take, I think, the complex numbers that you did earlier and create an input, an output, and overload plus and times. I think I might not bother overloading division since it's such a mess, but we'll see. So that's that. Again, for those celebrating this weekend, either Easter or Passover, enjoy it and have a good time if you're going home.